Hello everyone, welcome to Homework Help. If you find the videos useful, please subscribe to the channel. So in this video, we'll solve this problem using the concepts of derivatives. So as per the problem, historical data show that the amount of money sent out of Canada for interest and dividend payments during the period from 1967 to 1979 can be approximated by the model P equals 5 times 10 to the power 8 times E to the power 0.20015 t, where t is measured in years and t equals 0 in 1967 and p is the total payment in Canadian dollars. So let's start with part A. So in part A, we have to determine and compare the rates of increase for the years 1968 and 1978. So we have to compare the rates of increase. So for that we'll have to calculate the rates of increase for 1968 and 1978. Now the rate of increase for P, the total payment, will be the derivative of this P function. So the first step is to write the P function. Now in this P function, the input variable is T, which is years measured from 1967. So we can rewrite this given function P as P at T equals so this is the given function. So we can start by finding the derivative of this function. Now this is an exponential function with the base e. So the derivative of this function will be, now in this exponential function, 5 times 10 to the power 8 represents the coefficient of the exponential term. So that term will stay the same. So prime of p at t equals, so the coefficient stays the same, times the derivative of this exponential term, and that is equal to the exponential term as it is given, times the derivative of the exponent, and the exponent is 0.20015 t. So the derivative of this exponent will be times 1. Now 0.20015 is the coefficient of this exponent, so it will stay as it is, and the derivative of t is equal to 1. Now we can simplify this expression. So 0.20015 times 1 is just 0.20015, and we can multiply it by 5 times 10 to the power 8. So I got 100, 0.75, 0.000 times, so this is the expression for the derivative of the given function p. Now we have to find the rate of increase for 1968 and 1978. So let's start with 1968. Now the reference year is 1967. So for 1968, we'll have to sub in t as 1. So we calculate, so prime of p at 1 equals, so we sub in t as 1, and now we can evaluate this expression. So e to the power. So I got 1, 2, 2, 250, 217.2, and the unit is dollars per year because the unit of t is years. So this is the rate of increase for the year 1968. Now we can do the calculation for 1978. So for 1978, we should sub in t value. So we can do the calculation for t value. So we should do 1978 minus 1967, the reference year. And that is equal to 11. So we should sub in t as 11 in the prime of p at t. So we get now we can evaluate this expression. So I got 904 9700.2, and the unit will be dollars per year. So this is the rate of increase for 1978. Now we have to compare the rates of increase for these 2 years. So for that, we should divide the rate of increase for 1978 by the rate of increase for 1968. So we should do 9, 4. Now we can do this division. And I got 7.4. So that means the rate of increase for 1978 is 7.4 times more than the rate of increase for 1968. So now we are done with part A. So now we can analyze part B. So for part B, assuming this trend continues, compare the rate of increase for 1988 with the rate of increase for 1998. So the first step is to calculate the rate of increase for 1988. So first we'll have to find the t value we can use for 1988, and for that we'll do 1988 minus 1967, the reference year. So I got 21. So now we have to sub in t as 21 in the prime of p function. So we get so now we can evaluate this expression. So I got mm, and the unit will be dollars per year. So it's almost $6.7 billion. Now we can do this calculation for 1998. So first we'll calculate the t value for 1998. So this is equal to 31. So we'll sub in t as 31 in the prime of p. Now we can evaluate this expression. So I got 4.954 times 10 to the power 10, and the unit is dollars per year. So that's the rate of increase for 1998. So these are the two values that we got for 1988 and 1998. Now we have to compare the rate of increase. So we'll divide the rate of increase for 1998 by that of 1988. So we can do the calculation here. So 4 point. So this is the value for 1998. This is equal to, and I got again almost 7.4. So that means the rate of increase for 1998 is 7.4 times more than the rate of increase for 1988. So this should be the final answer for part B. So these are the steps you have to keep in mind to solve a problem like this one. So I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.